Today we are continuing with law of sines and cosines and talking a little bit about when to use which one. So in example 1, we're going to start off by drawing our triangle. And I'll put B on top so that you're used to seeing it drawn like this. We know angle A is 25 degrees, so we're going to label that. We know angle B is 75. And we also know that side A is 14, so the side across from angle A is 14. So the first thing you should notice is that you have two angles. So when you have two angles, the easiest thing to do is start off by finding our third angle, because we know that all of our angles together add up to give you 180. So we can just do 180 degrees minus the sum of our other two angles. So 25 plus 75 is 100, and then when we subtract 100 from 180 degrees, we get an angle of 80. So we already know angle C is equal to 80 degrees. Don't forget your degree sign. Okay, now what you should notice about this problem is that we have a pair. We have angle A and side A. So whenever you have a side angle pair, so we know that there's a side angle pair, that's when we should use the law of sines. So we're going to start off with the pair that we know. We have sine of 25 degrees over 14, so that's our matching pair, A and A. Angle goes on top because sine of the angle equals, so it doesn't matter which one of these we use. So let's just start off by finding B. So we know that angle B is 75, so 75 is going to go up here, and side B is going to be in the denominator. So to solve for B, we're going to cross multiply. And we're trying to get B by itself, so since it's being multiplied by sine of 25, we're going to divide by sine of 25. And that cancels this out, so we have B by itself. So this is what we're putting into our calculator. So making sure you're in degree mode, we're going to type in 14 sine of 75 divided by sine of 25, making sure to have parentheses after your 75. And we get that B is equal to 31 since it's a side, we're going to have three numbers after the decimal point. 31.998. And that is side B. So to find side C, we're going to do the same thing, but now instead of 75, we're going to use the angle for C, which was 80. So I have sine 25 over 14 again. So I'm still starting off with the one that I know, the A's. And this time I have sine of 80 degrees over C, because 80 degrees is angle C and this is side C. So again, we're going to cross multiply. Get C by itself. And so C equals, we're going to again plug this into our calculators. And we get 32.6235, and so that 5 after the 3 tells us we're rounding up. So we have 32.624. So that is all three values for problem number 1. Okay, let's look at problem number 2. So again, we're going to start off with the same thing, drawing a picture of our triangle, A, B, C. We know C is 20 degrees. We know side A, which is across from angle A, is 6. Side B across from angle B is 7. and these are what we're looking for. So unlike the past problem, we don't have a pair. We don't know a pair of A, B, or C. And we also don't have two angles that we can use 180 degrees for. So this time, because we have two sides and an included angle, which means the angle in between them. So two sides, angle in between them. This means we're going to use the law of cosine to solve for the side. Okay, so two sides, angle in between means that we're using law of cosines to solve for the other side. So the other side that we're missing is side C. So looking on your paper, to solve for the side, we're going to use the first equation. We have c squared equals. The first two variables are your other two sides. So here is c. My other two sides are 6 and 7. So I have 6 squared plus 7 squared minus 2, 6, 7, then cosine of the opposite angle. So opposite of side C is angle C, which is 20 degrees. And now to get C by itself, I have to undo the squared. Opposite of squared is squared root. So I'm going to square root everything. And so this is what I'm putting into my calculator. Square root 6 squared plus 7 squared minus 2, 6, 7 cosine of 20. And what that gives us is 2.463, since the 8 rounds the 2 up to a 3. And because it's a side, that's why we're using 3 decimal points. We have side C. So now, after we solve for this first one, we now have a pair. So we have C and C. So we can now use law of sines. So sine of, we want the angle on top with your sine. And 2.463 goes to the bottom. And this is what we talked about yesterday. So this is the part where you need to make sure the one you're solving for next, you want to solve for the smaller one. So out of 6 and 7, 6 is smaller. So we're going to be using 6 to solve for angle A. So 6 is the side, so it's going to go at the bottom. We don't know what angle A is, so we're going to just leave capital A. So always, always find the smaller side. Find the smaller angle. Using your law of sines, because if it's obtuse law of sines, it's not going to work. Okay, to solve for A, we're going to multiply both sides by 6. 6's cancel out. And to undo the sign, we have inverse sine. And that's what we're going to put in our calculator. And this gives us 56.4 because it is an angle, capital A. It is rounded to the whole number, so we can just leave it as 56 degrees. So now that we know 2 out of our 3 angles, to solve for our last angle, angle B, we can just now use our triangle sum theorem, which means they all add up to 180. So we can do 180 minus the sum of 56 and 20. So 180 degrees minus 76, which gives us 104 degrees. Which is why, notice angle B is obtuse. This is why we had to use the smaller angle first. Because if we use B, we would not have gotten the correct answer, because sine can't tell the difference between obtuse and acute. Okay, let's look at our last problem. So for problem number 3, here's my A, B, and C. This time we have all the sides. So side A is 8, side B 10, side C 12. And so when we have all the sides and we're looking for the angles, we're going to be using law of cosines. Because cosine works for all your angles and sine only works for the smaller ones, we're going to actually use the law of cosines to start with the largest angle. Because cosine always works and sine doesn't. So let's use cosine to find the largest angle. So if you're using law of sine, start with the smaller one. If you're using law of cosine, start with the largest one. So the largest angle is going to be opposite the largest side, which is 12. So we're looking for angle C. So using law of cosines, if we're trying to find the angle, look at your paper. It's your second equation of law and cosine. So we're going to use cosine of C equals, we want to first have the adjacent side. So next to C, the two sides adjacent or next to it are 10 and 8. So we're going to have 10 squared plus 8 squared. And then we're going to subtract the side across from C, which is 12. And divide it by 2 times your first two sides again, so the adjacent sides, 10 and 8. And now we're going to use our calculator. Again, if you're not really good at putting fractions into parentheses, you should be doing the top and the bottom separately. So 10 squared plus 8 squared minus 12 squared gives us 20. In the numerator, 2 times 10 times 8 gives us 160 in the denominator. And to solve for C, we need to undo the cosine. So we're going to use cosine inverse cosine, which is second cosine, 20 over 160, which gives us a value of 82.819, but because this is an angle, we're going to just keep it whole number, so it rounds up to an 83, and don't forget your degree sign for angles. So 83 degrees is angle C. And now that we have a pair, C and C, we can go back to using our law of sine. So sine of 83 over 12 equals. So at this point, now it doesn't matter which one you choose. You can start with the smallest one. So if we wanted to find sine of A, if we're solving for angle A, we can use 8. But once you get the largest one out of the way, it doesn't matter anymore, because there's no way you could have two obtuse angles in a triangle. Okay, so let's solve for A. Multiply both sides by 8. And then to undo the sign, we're going to inverse sine. Second sine, 8 sine 83 divided by 12. So we get a value of 41 degrees for angle A. And now we have two angles. So to find our last one, we can again use our triangle sum theorem, which tells us that they all add up to 180. So angle B is equal to 180 minus 41 plus 83. So 180 degrees minus 124, which is 56 degrees. And now we are done finding all three angles for number 3.